Hi students, today we have to discuss about a new chapter, structure of atom. What is the structure of an atom? In the previous chapter we discussed about atoms and molecules, and also we discussed about the molecular formula, atomic mass, etc. Here we study about atom, structure of an atom. In the previous class we studied that atom is an indivisible particle, but here atoms consist of different particles, subatomic particles. It is the central part, nucleus of an atom. It is the central part of an atom. It consists of neutron and proton and electrons in the outer part of the nucleus. It is the structure of an atom. We have to study the basics of this structure of an atom, also the history of the structure of atom. An atom consists of positive and negatively charged particles, that is electron and proton. Neutron doesn't have any charge. Who identified electron? Firstly, J.J. Thomson identified an electron as a negatively charged particle. He accidentally identified a negatively charged subatomic particles. He named it as electron. It was J.J. Thomson. And before that, there is another invention. It is called canal ray invention. Canal ray. Goldstein accidentally observed a positively charged nucleus, a positively charged particle in the nucleus, in the central atom. But he could not identify more about that. When J.J. Thomson invented electron, it leads to the invention of proton. What are the properties of proton? Property of protons is just opposite. The charge of the proton is just opposite to that of the electron. Canal rays are identified by E. Goldstein in 1886, which is a subatomic particle. Proton is a subatomic particle having a charge equal in magnitude but opposite in sign to that of the electron. The charge of electron is same as that of the proton, but the sign is opposite. Okay. What is the relation between the mass of electron and proton? There is a relation between the mass of electron and proton. It is not equal. Proton is approximately 2000 times larger than that of the size of the electron. Okay. Proton is approximately 2000 times larger than that of the electron. Proton is larger. It exists in nucleus. But electrons are revolving around the nucleus. This central portion is called the nucleus. Okay, we have to study about the discovery of an atom. Many scientists studied about the structure of an atom, and the scientists explained about these atoms and nucleus. We have to study it. Then Thomson's model. It is the first theory about the structure of an atom. He explained about an atom. Atom is like a watermelon or a Christmas pudding. Atom is like a watermelon, and he explained that the outer covering is the positively charged sphere. Then the electrons are embedded in it. The electrons are present in an atom like the seeds in a watermelon. Okay. Thomson proposed the model of an atom to be similar to that of a Christmas pudding or like a watermelon. He explained the structure of atom in that way. It was the first explanation, first theory about the structure of an atom. The positive charge of the atom is spread over like the edible part of the watermelon, red edible part of the watermelon. The positive charge is spread all over the watermelon like the red part. Okay. Then, while the electrons are placed in the positively charged sphere like the seeds in the watermelon, the electrons are present like the seeds in a watermelon. That is the theory, that is Thomson's theory of atomic structure. The postulates. An atom consists of a positively charged sphere and the electrons are embedded in it. That is the first postulate of Thomson's theory. Then the negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. The positive and negative charge will be cancelled and it is neutral. Atom is called as a neutral. That is the theory of Thomson's about the structure of an atom. Then we have to study another structure. Then the another theory is Rutherford's atom model. Rutherford is a great scientist. He made a lot of experiments with the atoms, with the particles. So, for finding his model, he conducted an experiment. It is a famous experiment called as alpha particle scattering experiment. Alpha particle scattering experiment. Alpha particle is a subatomic particle. It is similar to helium. Helium means atomic mass of helium is 4 atomic mass unit. The mass of the alpha particle is same as that of the helium. That is, the mass of the alpha particle is 4 atomic mass unit. So he conducted an experiment. It is alpha particle scattering experiment. He placed a source of alpha particle scattering. It is the source, and he placed a gold foil here, a gold material here, and a detecting screen like this. This screen detects the particles scattering and reflection and transmission. Some particles transmit, some particles reflect, and it deviates. These alpha particles detected by this film. It is detector. It is gold foil and is source of alpha particle. In his experiment, he passed he passed the alpha particle from a source to the gold foil, and he conducted that experiment in that way. We have to analyze that experiment, but there are some questions. Explain the experimental setup for Rutherford's model. Rutherford made this atom model by conducting an experiment. What are the experimental setup? It was the alpha particle scattering experiment. It consists of a gold foil, a thin gold foil. Okay, it was about 1,000 atoms thick, narrow thick. Then this alpha particle ejected from a source. Then he analyzed the result. This is the source. He ejected alpha particle from this source to the gold foil. That is the experimental arrangement of Rutherford's scattering experiment. Then, what is alpha particle? What is alpha particle? Alpha particles are doubly charged helium ions since they have a mass of 4 atomic mass unit. The fast moving alpha particles have a considerable amount of energy. When this helium nucleus, when this alpha particle passed heavily with high speed, it consumes an energy, and it passed through this gold foil, and he analyzed the result. He explained the structure of atom by using this analysis. So then we have to discuss about the results of Rutherford atom model. What are the results of alpha scattering experiment? It is the gold foil. Just try to draw this figure, and it is the almost figure of gold foil. Okay, we have to discuss the results of Rutherford's atom model. The first one, most of the fast moving alpha particle passes through the gold foil. You have to draw it. Most of the fast moving alpha particle passes through the gold foil. You have to draw it. This alpha particle, it overcome the gold foil without any deviation. Most fast moving alpha particle passes through the gold foil without any deviation. Then another one. Some of the alpha particles were deflected by the foil with small angle. There is some alpha particle deviated with some angles. In that way. And another one. Some particles appear to be rebound, get reflected back, get deflected back. It is in this way. Okay, some particles, only a few particles get deflected back. It is the experimental observation of Rutherford's alpha particle scattering experiment. Most alpha particles pass it. Some alpha particles get deflected and a few alpha particles get deflected back. That is the result, observation of Rutherford. So what are the conclusions from alpha particle scattering experiment? What are the conclusions made by Rutherford? Okay, most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without any deflection, without any deviation. That is this. Most of the space inside an atom is empty. That is a conclusion by Rutherford. His second conclusion is that very few particles were deflected from their path, indicating that the positive charge of the atom is occupying very little space. Some particles deflected. Okay, some particles deflected it indicates that some positively charged particle is present at the center portion. It occupies with a little space. Okay, then a very small fraction of alpha particle deflected by 180 degree. That means it deflected back. It is indicating that all positive charge and mass of the gold atoms were concentrated in a very little small volume within that atom. Okay, the small space occupies the whole charge and mass. That is the conclusions made by Rutherford. Then what are the postulates made by Rutherford from his experiment? And it is the postulates he explained his own view about the structure of an atom. There is a positively charged center in the atom called nucleus. The central portion is called nucleus. Nearly all the mass of an atom resides in the nucleus. The mass is concentrated inside it. So, the proton and neutron included in that nucleus. The electrons revolve around the nucleus in a circular path. The electrons are revolving around the nucleus in a circular path. These are explained by Rutherford. Then the size of the nucleus is very small as compared to that of the atom. As compared to the size of the atom, the size of the nucleus is very small. Okay, size of the nucleus is very small compared to that of the size of the atom. These are the postulates made by Rutherford. Then drawbacks of Rutherford's atom model. Rutherford explains a lot of things and it is important. His experiment is a famous experiment and it is the drawback. He explained that Rutherford's explanation about the motion of electron is that electrons are moving in a circular path around the nucleus. It is nucleus and the electrons are revolving around the nucleus and in a circular path around the nucleus, and when it radiates energy, the radius continuously decrease and then finally fall into the nucleus. He explained that if this electron radiate energy, the electron continuously radiate energy and fall into the nucleus. It is not possible. It is the drawback. If it were so, the atom should be highly unstable and matter would not exist. It is not possible. If it's so, the matter doesn't exist because of the instability of the nucleus. That is the drawback of Rutherford's atom model.